Welcome to the Smooth Scaling podcast, where we focus on system design for high traffic. And we deep dive into things such as scalability, resilience, and performance. I'm your host, José, and today we have Martin Larsen with us in the podcast.
Thanks, and great to be here.
Good to have you. And Martin, you're a distinguished, let me check my notes, distinguished product architect at Qt. I think it's a very distinguished title.
Yes.
And you've been in Qt from the very beginning, from long time ago. So before we go into designing for failure, can you just tell us a little bit about yourself, your background, how you got to Qt, how the journey has been?
Sure. So I'm 44 now, and I started in Qt 14 years ago, maybe, around that time. Before then, I was doing a bunch of like web application work. I took a master's degree in the IT university. And then I started with a company doing software for the public sector. And was there for a couple of years and another place. And then I got the opportunity to be here at Qt, where I was as you said, the first developer that was hired. I happened to know the founders from a previous job, so I guess they liked me. So, so I jumped on board here from the very beginning. Yeah,
very cool. And you've been here for those 14 years. So I'm guessing that a lot of things have changed since then.
I've also been doing all kinds of things. I mean, I was a fairly new developer at the time, and since then I've obviously been coding a lot of the platform, but also moved into other roles like product management and architecture and cloud technology, cloud architect, and now I'm sort of found my place in product, I guess.
And very happy for that as well, as someone working in Qt too. So maybe we can start talking a little bit about design for failure, right? And can you maybe from someone that doesn't know a lot about the topic, you could argue, well, do I need to design for failure? Can I just design for success and make everything always working correctly? So can you tell us a little bit about design for failure, the approach, and where do you think that it applies?
Yeah, so for me, designing for failure is around embracing that no matter what you do to make your platform resilient, you're still going to fail. So having that in mind, you can achieve 99.99 something, but eventually you're going to fail. And what happens then is what is the sort of the blast radio of what happens when you fail, right? So for me, this is very, very important. And you can also say the more nines you want in your availability, the more expensive it's going to be, right? So starting to look at the different approach and saying, okay, we know that we are going to fail. How are we then going to survive when we fail? How are we going to perform? What's the user experience going to be? And what can we live with as a degraded user experience?
And was this was it from the very beginning when you joined 14 years ago? Was the designing for failure kind of in your mind as part of the system design already from the beginning there?
Yes, it was back then 14 years ago. This was a kind of a hot topic, I think. The movement of the cloud has just started, and with the cloud, you start questioning some of the design patterns that was usually done, right? So in the past, you would probably just have a web application server and then a SQL database, right? And that would be sort of your architecture in many cases. But with the cloud and also a little bit before, right, you started to see all these new kind of services, message bus and NoSQL databases and different different message queues and so forth. These technologies were sort of gaining at the time, and alongside of that is also the thought about, okay, let's try to design something that when it fails, it's still operational, right? So, yeah. So from the very first, it was very much a thing. I remember also we had some discussions or some talks about this. One with the previous CEO Nils, actually, on this topic, where he was saying like, well, what are we gonna do with maintenance windows? Like when we need to upgrade something in our system, what are we then gonna do? And I was sort of on the other side there, saying, hey, we're not going to have any. And he was looking a little bit crazy at me because that's kind of how we did it in the previous, before the cloud. It was maintenance windows and technology that had to be taken down to be replaced and so forth. So that was very much a thing on my mind back then.
I think it's quite good to know. I think interesting to know so that it was already from the very beginning there. One question: do you think that designing for failure, is it applicable to every company, or do you see any use cases or scenarios where it's maybe more of a no need to pay for that work? And
I think there are levels of it, right? I mean, there are things that you can do easily, which, I mean, I would just suggest everyone tries to apply. And then it goes, I mean, for me, it's more than just choosing some technology or building in resiliency in your code, right? It's also about processes. For instance, like how do we deploy our code? Do we deploy to all our customers or all of our environments at the same time, or do we sort of do it gradually, or all those things that you need to think about? You can also say some of the other thoughts around deploying frequently is also about this, because we all know that deployments are going to fail from time to time, no matter what you do in terms of testing and so forth. You're going to fail on deployments eventually, right? So deploying as small a change as possible makes sense, because the risk of you failing is lower, and you get also to practice deploying, right? Whereas before the cloud, it was like, let's make a release every half year or 3 months or whatever, and then you would spend 7 days trying to actually make that work. So for me, designing for failure is something that flows through the entire R&D organization and the way you actually work.
Those examples that you just gave, would you say that they're all kind of within the simple part of design for failure? Because you said that you do think that for kind of those ones would apply for everyone. Is there some more on the other side, the more extreme ones? Do you have some examples there?
Yeah, of course. I mean, you can take it all the way to the extreme. Let's say our data center crashes. I mean, it's unavailable. Then what are you going to do? Are you able to run the entire setup in a different data center, for instance? And that's kind of a little bit of the extreme, because how often does that really happen? I've been with Curate now for 14 years, right? And I've never seen an AWS data center go down. Like maybe briefly in some regions, happily, luckily not in the regions that I've deployed code to, but still, it's only like a very short amount of time compared to what happens if you deploy a faulty application, right? There was this Norwegian trading platform here the other day. I don't know if you read about that, but it was down for like a day because they deployed bad code, right? So, yeah. So compared to those hardware failures or like the data center failures, they happen very frequently, and they are very expensive to actually do something about, because you have to replicate data across regions and all that. But whereas the sort of, let's just try and deploy this code to a small part of our code base and see what happens, that could have, it's not that expensive to do, actually. So, yeah, definitely some of the process things are pretty easy to implement, I would say. Whereas when you get to the having a backup database cluster or something running, right, it gets a little bit more expensive then. And then it's of course a cost benefit analysis you kind of have to make, like what's the cost of being down versus what is the cost of actually building in this resiliency.
I really like that, the way you kind of exemplify that, and also the fact that it's kind of, you're basically preparing for worst case scenarios, or at the very least, you're discussing those worst case scenarios. And maybe there's the very extreme ones, like you're saying, a data center is down. Those you might, as a company, you might decide whether you want to kind of address that one and be able to handle it or not. But at the very least, you're having those discussions, so you know where you stand, I guess, across that spectrum of things that might go wrong. I think it's a really nice approach to developing software.
Like anything else, there's like in software development, there's trade-offs, right? So this, of course, there's a cost trade-off to this, and there's also, I mean, when you have resiliency, you also have to test that it works, right? Because if the data center is down once every 10 years, then you need to be ready for it, and actually, like when it goes down, then you have to have the confidence that you're gonna fail over to something else. So that is also a cost, right? And even though the data center never fails, the cost is still there.
When I think this might be a bit of a hard question, but for people listening, how do you think about when approaching that cost trade-off, right? So how is there any guidance that you can give to people that are kind of starting to discuss that or to think about that? What should the considerations be?
Yeah, so like you have to sort of take the business into the fact, right? Because it's not the cost of getting the platform up and running again. It's the cost of actually being down, and the revenue that you're not going to get, the what's it called, bad press and so forth. For us in Qt, it's pretty obvious because we are here to serve our customers when they have the most critical hours. So if we are down, then it's very expensive, as you know. So for us, the calculation isn't that difficult, right? There's still some that we take. I mean, is it worth it? The end. I mean, obviously, we can also spend our money on improving user experience or something else, which will also benefit our customers, right? So it's always a balance, right? Like any other product enhancement in the system, you have to balance it.
So on kind of looking at Qt, is there any specific ways that we have that you would like to call out on how we have designed our system, our platform for failure?
Sure. So we can take a very specific one. So again, we have these very large traffic spikes. It could be like 100x in a few minutes. So in order to do that, of course, we can look at the infrastructure and design it in a way, the application in a way that it scales horizontal, which of course we have done. This is fairly common to do nowadays, but back then, in 14 years ago, it was something less seen. But basically, this is about having stateless servers so that you can add more and quickly get them up and running. So in minutes, you have 10 times the capacity as normal, right? So that's like one very specific thing, but there's a bit of twist to this one because that you may not always be able to scale fast enough. So that's kind of the worst case scenario for us because you hit the 100% CPU or whatever limit you reach, and and you're just down, right? So all end users are affected. So that happens that we hit those resource limitations. So in order for us to survive that and not go down, we actually ask all the end users to stop polling us as fast as the same interval as they usually do. So we say usually let's just for example, usually you are polling your status every 30 seconds. Now you're doing it every 5 minutes instead. So that, of course, reduces the load on our servers, and we are able to handle more end users while we scale up in auto-scaling, right?
That's pretty smart.
That is, and this is kind of an important thing, I think. This is this degraded user experience because, of course, there is a consequence for the visitors, the people waiting in the line. in that they're not going to get updates to their progress, and they don't really see how they are progressing in the waiting room and so forth. But that is sort of acceptable if the alternative is that we are down. Yeah. And this degraded user experience is something that is something I think everyone should think about. Even if you have like a simple web shop or something like that, and let's say you have these widgets that suggest personalized suggestions to you. This is what you probably should buy, right? Those will counter in if they're really good. They will take just live events from the session that the user have, feed it into some engine, and then it will come up with suggestions, right? So this is pretty resource intensive thing to have, right? Let's say you're on the load and and you're hitting your threshold. Then would it be better to crash, or would it be better to just turn off this personalization and maybe not render it at all on the website? Of course, it's a degraded user experience. It's also going to cost you a little bit because they're not going to buy those additional products, but they'll still be able to shop for the goods that they actually came for, right? So the end user is pretty happy. They might not even notice that it's not there, and the service is up and running still. And these are one of the probably less expensive things to do, because it's basically just a feature switch. You can toggle it on and off if you are in trouble, right?
It reminds me actually of I think it was also some years ago with Netflix that I read that they also have something similar within their systems, right? So if you're opening up your Netflix page, you're getting all the suggested for shows, but if that service is down, the app is not crashing. You're just getting some standard list of suggested shows, right? So I guess it's back to the graded experience, but still giving the user some experience, and I can still get to the show that I want to watch.
Exactly. And this is for me like the main thing of designing for failure, is that you keep your core service running while those added benefits or the nice to have features are sort of disabled.
So thinking a little bit about kind of has there been, so you mentioned that 14 years ago in Qubit, there's some that we were already thinking about. Was there any sources of inspiration at the time? So kind of where did that come from? Do you know?
Yeah, so I can only talk about my own inspiration, of course, but we already discussed the cloud movement was coming, and with that we also had a focus on this. But one other thing that I personally was inspired by was these peer-to-peer programs. Maybe for file sharing and piracy and all the things that came along with it. But those services were kind of maybe a little bit dying at that time, but at least up to the years up to were very popular. And I did some of my masters and some of my projects at school around peer-to-peer networking. And those are kind of, systems where they are totally atomic, right? So you have one node and it does everything. And they all do that. So if one node goes out, no one will know. Exactly. So I think I got a bunch of my inspiration from that. And I also took some of those principles into the product. Back then, we only had like a few services to choose from with Amazon. It was like a simple database and S3, I think, for object storage. So we had to do a little bit more of this ourselves than you have to do today, because today it's built into messaging platforms and databases, NoSQL databases, and so forth. But back then it was a little bit different, so we had to build some of it ourselves. So we actually implemented a peer-to-peer protocol and put it into the system. But I was definitely inspired by that. I thought that was very fascinating, and along the same lines. Of course, there was also lots of other companies doing similar things and advocating for chaos engineering and all that.
Very cool. And so maybe more thinking now on the other side, at least one of the sides is kind of the actual causes or the reasons for failure, right? And in the many years that you've worked here, are you able to just summarize kind of what are the main causes for failure that you see, maybe in Qt, but also out there in the industry?
Yeah. So of course there are like infrastructure things. So a server goes down, a database fails, those kind of things. I think those are fairly easy to get around nowadays, or at least easier, because it's been built into all these other products. So you have the infrastructure thing. So, and that's where it sort of is on borderline with designing for failure and like just choosing the right architecture, because they kind of go together, because a lot of this design for failure has actually been built into those components. So, but of course that's there if you're running a website, you want to keep that application stateless, and you want to have multiple instances, because maybe across availability zones or data centers even. So that's one thing. I think the worst, or the one thing that causes the most problems, at least in my experience, is humans, though. Yeah, that's where we are, right? So bad code, faulty deployments, those kind of things. So that's also, again, why I think it's very, very important to take this to the process layer as well. For instance, when we deploy something, we will do it very, very carefully, like deploying it to, say, single, what we call partitions, but basically logical groupings of customers, so that if we fail, that deployment is at least only going to affect those few customers, and we can roll back, or we can move customers to a different partition, which is healthy, right? So thinking lines, those kind of lines.
Yeah, and I really like the aspect of the process, right? Because yeah, you're saying it. Humans do bring kind of. We are human. We make mistakes, and I've experienced some of our postmortems, right, where the focus is on, okay, but how do we improve the processes and the systems so that the next human is not actually able to make that mistake because we've added some guardrails around. I think that's also very interesting to consider.
And I think I have maybe a third category as well, which is those errors that you just don't realize are there until the system is used in some specific way. So let's say you never, like, customers is using the system in some way that you didn't think of, and it's putting some load on some database somewhere. And those are sort of things that just happens, it could happen anytime, basically. And what do you do about those? How can you actually make sure that your service is still working, even though that thing just happens to blow up, right?
Yeah.
And those are probably the trickiest ones also, because you have to sort of build something into the application that'll register that this happens and then fail over to something else, right?
And I guess that's also where we haven't touched on it in this discussion, but where the monitoring and tooling and alerting will also come into play, so that even if it's something that somehow we didn't account for, that we can at the very least react fast to address it.
But that's not really designing for failure.
That's true.
It's more like reacting to failure.
Yeah. But you can design how you react to the failure, right?
Of course. Yeah, that's processes again. But it's also that, if those failures happen, then the system should heal itself and recover, right? Which is the difficult part.
Very good. And I think we're getting to the end of the interview here. Maybe one final question on kind of, is there anything specific that you're keeping an eye on or being excited about in this space in the future?
I think, I like to see actually how the company has a continuous focus on this. We are about to replace one of the databases that we have. with another alternative. And we've been very happy about that database, actually. It's been working like smooth, and we a lot of our logic is built up around this database. And now we have to replace it with something else that we are not really that sure about how that will work. So we actually starting to think, okay, how would we actually survive a total database crash? Yeah, like how would the waiting room behave if we didn't have the database? Could we still, serve users without it? And how one of the things that we have is that we have this consecutive ordering. So visitor number 1 will have queue number 1, and then up to n, right? So in a fourth running manner, just like as you know from the pharmacy or in the physical world. And we made this choice back in the days because we were kind of the first ones doing a virtual waiting room, and we wanted the experience to be similar to that one that you have in the physical world. But now we're starting to question, does this still hold? Are people so used to waiting rooms, virtual waiting rooms nowadays, that we don't need to have this fourth running thing? And that having a fourth running sequence in a distributed system is actually quite hard to do. And it kind of, again, puts it, the responsibility in one component. And you can do all kinds of things to make this component resilient, but eventually it's going to fail, right? So what if that fails? Can we still run the waiting room without this this fourth running numbering? That's one of the things I'm looking forward to try to crack.
That sounds exciting. So I think, and one thing maybe that we can agree on is that you'll come back to the podcast at some point and tell us how kind of that research and that part of the work went. And that's it for this episode of the Smooth Scaling Podcast. Thank you so much for listening. If you enjoyed, consider subscribing and perhaps share it with a friend or colleague. If you want to share any thoughts or comments with us, send them to smoothscaling@kiwit.com. This podcast is researched by Joseph Thwaites, produced by Perseo Mandilo, and brought to you by Kiwit, your virtual waiting room partner. I'm your host, Jose Quaresma. Until next time, keep it smooth, keep it scalable.